NASA has discovered something incredible in the deep sea, in the darkest and deepest parts of the oceans. In fact, NASA is also exploring the oceans and making breathtaking discoveries there, from mysterious oxygen sources at depths of 4,000 meters to creatures that look like they came straight out of a sci-fi movie. What the researchers have found down there will blow your mind, and we're diving right in. Why is NASA, of all organizations, exploring the deep sea? It's simple. In many ways, the oceans are just as inaccessible and mysterious as distant worlds in space. Let me know in the comments whether you'd rather be an astronaut or a deep-sea diver. I'm curious to hear your preference. And if you're just as fascinated by the mysteries of the oceans as I am, then hit the subscribe button now. It costs nothing, you'll never miss new discoveries again, and you'll be helping me a lot. Thanks a lot, everyone. The parallels between space and the deep sea are truly astonishing. Extreme pressure conditions, total darkness, and bizarre life forms abound, and that is exactly why NASA has a huge interest in exploring the deep sea. Although it is known as a space agency, it also conducts all kinds of research in Earth's oceans, which makes perfect sense because deep-sea life can provide insights into possible extraterrestrial life on other planets. But before we look at NASA's specific achievements in the ocean, let's take a quick step back in time. You may have heard the claim that we know more about our moon than we do about our oceans. This assumption is actually correct, since we have more detailed information available about the moon's surface than about the ocean floor. For example, the moon has been mapped in great detail by numerous space probes, manned missions, and satellites, and we have high-resolution images and data covering its entire surface. In contrast, however, only a small portion of the ocean floor has been mapped at comparable resolution, as mapping the ocean floor is far more difficult due to the technical challenges associated with depth and extreme conditions. Deep-sea probes and remotely operated vehicles must withstand extreme pressure, darkness, and often harsh thermal conditions. Historically, more attention and resources have also been directed towards space exploration, particularly during the Cold War. Ocean exploration is of paramount scientific and ecological importance, yet it has received less public and political attention. All of this prompted the Royal Society of Arts Journal to write in 1957 that the deep oceans cover more than 2/3 of the Earth's surface, and yet more is known about the shape of the moon's surface than about that of the seafloor. Of course, we've come a long way by now. 23.4% of the seafloor has been mapped in high resolution using echo sounder technology, and despite this progress, a large portion of the seafloor remains unmapped. The Seabed 2030 project, for example, has set itself the ambitious goal of fully mapping the entire seafloor by 2030. NASA will play a major role in exploring the oceans and already has a few exciting projects underway that will also advance our exploration of space. NASA was founded on July 29, 1958, when US President Eisenhower signed the National Aeronautics and Space Act. The primary purpose of NASA's founding was to promote civil aviation and spaceflight in the United States, and it was intended to advance scientific research and exploration of space and Earth's atmosphere. It was also tasked with developing technologies and vehicles necessary for space and aviation exploration and expanding our understanding of atmospheric and space phenomena to enrich human knowledge. In 1978, NASA began to focus intensively on Earth's oceans when it launched its first oceanographic satellite, CSAT, specifically designed for this purpose. This satellite was capable of collecting data on sea surface winds and surface temperatures, wave heights, and other characteristics, and this data helped NASA learn more about our planet's oceans and their influence on the global climate. The extreme conditions in the deep oceans of Earth resemble those expected in the oceans of other celestial bodies, such as Jupiter's moon Europa and Saturn's moon Enceladus, and more so than one might think. In addition to CSAT, NASA operates numerous other projects dedicated to ocean research. For example, during the NAMO missions at the Aquarius Reef Base off the coast of Florida, astronauts are housed in an underwater research laboratory where they work in a simulated space environment underwater to prepare for future space missions. The Aquarius Reef Base is the world's only permanently manned underwater research facility. It is located about 19 meters below sea level and consists of living and work units. The cramped and isolated conditions resemble those on the ISS and offer optimal training opportunities. Let me know in the comments if you dare to work for several days under these conditions. I have to admit that I wouldn't necessarily trade my studio here in the basement of the planetarium for such a cramped environment, especially since there's definitely no pizza there, though a frutti di mare pizza would actually go pretty well. But of course, for the astronauts, it's important training on the way to space. To date, there have been 23 NEMO missions during which astronauts worked together underwater for up to 3 weeks and even had the opportunity to don deep-sea diving suits to get a sense of what spacewalks might be like. But NASA is also testing a wide range of technical developments, deep-sea drones for example, autonomous underwater vehicles that must withstand extreme pressure and temperature variations, which perfectly match the conditions on other icy moons. These technologies must operate autonomously as radio communication is very limited at great depths and over long distances. It is also of great importance to study extreme life forms on Earth. The discovery of life forms in extreme environments, such as the hydrothermal vents in the Hadal zone of the Mariana Trench, shows that life can exist and thrive under such bizarre conditions, so why not in space as well? The moons Europa and Enceladus have liquid oceans beneath their icy crusts. On Europa, this ocean lies beneath a 10 to 30 kilometer thick layer of ice, while on Enceladus, it has been detected through geysers that eject water vapor and ice particles into space. It is believed that hydrothermal activity occurs on the seafloor of these oceans, similar to hydrothermal vents on Earth. These heat sources could provide the energy necessary for life to exist. With the Europa Clipper mission, NASA aims to determine whether conditions on Europa could support life as we know it. In 2030, the spacecraft will reach Jupiter and conduct numerous on-site tests. Europa Clipper will be equipped with a variety of scientific instruments, including cameras and spectrometers, to map and analyze the surface in high resolution. There will be radar devices to examine the ice layer and the waters beneath it, as well as thermal instruments to detect temperature differences and identify potential hydrothermal activity. Much of this technology has already been tested by NASA in Earth's oceans and is now being applied in space. The ocean on Europa could reach a depth of up to 100 kilometers. The Mariana Trench is a mere 11 kilometers deep, but scientists estimate that the hydrostatic pressure at the bottom of Europa could range between 130 and 260 megapascals. The pressure at the bottom of the Mariana Trench is about 110 megapascals. Both locations therefore require robust technologies that need to be researched. For example, there is the deep-sea submersible limiting factor, which can dive deep into the Mariana Trench and withstand depths of over 10,900 meters. That's not enough for Europa yet, but the researchers still have a little time to develop a suitable interplanetary submersible. In the Valkyrie project, which stands for Very Deep Autonomous Laser-Powered Kilowatt Class Yo-Yoing Robotic Ice Explorer, scientists are already researching the feasibility of a laser-powered cryobot capable of melting through the ice sheet on Europa to explore the ocean. And in the IceFin project, researchers are testing a small torpedo-shaped robot that can drill through ice layers and dive into subglacial oceans. IceFin has already been tested in Antarctica to trial the technology that could one day be deployed on Europa. The discovery of life in the solar system would have enormous implications for the likelihood of life throughout the universe. We could then assume that life is completely normal and that little bubbling aliens are the norm in other star systems. But even the creatures on our own planet sometimes seem otherworldly. Let's take a look at some of the most breathtaking inhabitants of our oceans. First, let's briefly clarify what the deep sea actually is. There isn't really a single uniform definition, but a relatively widespread view is that the deep sea begins 200 meters below the ocean's surface. And according to this definition, 88% of the world's oceans fall into the deep sea. The deep sea is also characterized by the fact that it is, for the most part, completely dark. Without light, however, there is no photosynthesis, but life always finds a way, and that's why there's another solution in the deep sea hydrothermal vents. Here sulfides, compounds of metals and sulfur, emerge from the seafloor, and clever strains of bacteria use precisely this as their basis for life. These bacteria can live off these inorganic substances, an ability known as chemolithotrophy. There is even a relatively well-accepted theory that these black smokers are the birthplace of the first life on our planet. Thus, it is possible that even without light, numerous creatures thrive in the deep sea, and all of them are absolute survival experts. To survive in this inhospitable, dark place, many of them are surprisingly large. Take a look, for example, at this giant isopod here. It grows up to 45 centimeters in length and weighs up to 1.7 kilograms. Another well-known example of deep-sea gigantism is the giant squid. Just how large these animals can actually grow remains uncertain. Most researchers consider 8 to 12 meters to be a realistic estimate. These deep-sea giants live at depths of up to 1,000 meters and can even pose a threat to sperm whales. And here is one last example of deep-sea gigantism, the Japanese giant crab. It is the largest living species of crab and also the largest living arthropod. Measured from leg to leg, they can reach up to 4 meters in length. But what is the reason that so many species in the deep sea can grow to such gigantic sizes? One would assume that, especially in the deep sea, where there is little light and resources are scarce anyway, creatures would tend to be smaller in order to conserve energy. First of all, it's important to note that not all deep-sea species are this huge. Of course, there are also very small creatures there, such as the vampire squid, which lives at depths of up to 1,000 meters, and at 30 centimeters in size is actually one of the smallest squids. Deep-sea gigantism is therefore a survival strategy employed by some species, but by no means all of them. These creatures consist largely of water themselves, and in fact, it is the water and the rather gelatinous consistency of these creatures that allow them to grow so large, since they do not have to fight against gravity like we humans do here on land. This explains why gigantism is possible, but not why it makes sense. The reason for this lies in two biological rules, Kleiber's rule and Bergmann's rule. Kleiber's rule states that larger animals generally function more efficiently. A cat, for example, which weighs 100 times as much as a mouse, has a metabolism only about 32 times higher than that of a mouse. Giant animals that swim in the depths of the oceans rely on food falling from above, and since food is often scarce, they have a strong incentive to become more efficient and therefore larger. Bergmann's rule is a general correlation between increasing body size and decreasing temperature. It states that larger species tend to be found in colder environments and smaller species tend to be found in warmer regions. The larger an animal is, the less body surface area it has that comes into contact with the surrounding environment relative to its volume. But the deep sea has even stranger creatures to offer. One of them is so bizarre that it could actually pass for a xenomorph. Just 200 years ago, not that long ago, it was assumed that the deep sea was completely devoid of life. That's because the technology available at the time made it impossible to find any animals there. It wasn't until 1960 that the Swiss Jacques Picard and the American Don Walsh succeeded in diving down into the Mariana Trench in a submarine, and then 50 years passed without anyone diving into the Mariana Trench in a submarine again. It wasn't until 2012 that James Cameron dived into the depths once more. Since then, we have discovered unique creatures such as the black dragonfish, truly one of the blackest animals in the world. Its surface absorbs 99.5% of the light. It's virtually impossible to spot it underwater. It's practically the black hole of marine life. It wasn't easy for the researchers to track down this fish at all because even when you shine a bright light around in the deep sea, the Pacific black dragonfish simply appears as a deep black surface. For the Pacific black dragonfish, darkness is, of course, an extreme evolutionary advantage, as it cannot be detected and can in turn sneak up on prey unnoticed. British researchers have succeeded in developing an artificial material that is even blacker than the Pacific black dragonfish. It reflects only 0.035% of the light, essentially nothing at all, and the reason for this low reflectivity is the fabric's composition. It consists of countless multi-walled carbon nanotubes arranged vertically on an aluminum substrate, so in a way they have artificially mimicked the pigment layer of the black dragon's skin. Such super black materials are immensely important for the further development of telescopes, satellite dishes, or other metallic sensors used in space technology or photovoltaics, since these are designed to absorb as much sunlight or infrared radiation as possible while reflecting very little. The reason for the strange appearance of deep-sea creatures is of course the nature of their environment, and a new discovery beneath the Pacific Ocean fits right in. The Melanesian marginal plateau, whose history stretches back millions of years to the time of the dinosaurs. Through extensive research, scientists have pieced together the puzzle pieces of this geological mystery and concluded that this massive underwater plateau was formed by 4 separate phases of volcanic eruptions, each with different causes. The Melanesian border plateau lies east of the Solomon Islands in the Pacific, and the seafloor there is dotted with countless underwater mountains and massive deep-sea volcanoes. Until now, it was assumed that structures like the Melanesian border plateau were formed by single, fairly sudden volcanic eruptions. But we were quite wrong about that, as a team of researchers has now discovered. The Melanesian marginal plateau actually formed in 4 phases, as we now know. By analyzing rocks from different geological periods that the researchers retrieved from the depths of the ocean in this region of the Pacific, they were able to date these phases with relative precision. During the Cretaceous period, about 120 million years ago, the formation of the plateau began with a massive eruption of basaltic lava. This created a vast underwater expanse that likely did not rise above the ocean surface at the time. About 45 million years ago, a portion of the Pacific seafloor drifted over a hotspot in the Earth's mantle known as the Ruruto-Arago hotspot. This led to the formation of an underwater mountain range with islands. The Melanesian Marginal Plateau then drifted over the Samoa hotspot. This hotspot is still active and forms the present-day Samoan Islands. Over the last 3 million years, tectonic movements along the Tonga Trench have triggered new volcanic eruptions on the plateau. The Tonga Trench is a deep-sea trench with a depth of 10,882 meters, making it almost as deep as the Mariana Trench. So we had 4 phases, one 120 million years ago, one 45 million years ago, one 13 million years ago, and one 3 million years ago, all of which led to the formation of today's Melanesian Marginal Plateau in the Pacific. The discovery of the Melanesian Marginal Plateau and its complex history of formation has truly far-reaching significance for the geosciences. On the one hand, it teaches us more about the evolution of the Earth's crust and mantle, and the new study shows that large underwater structures, which at first glance appear to be the result of a single cataclysmic event, can in fact be built up over long periods of time through multiple volcanic eruptions. And we can use these findings to develop more accurate models for the formation of underwater structures and to better understand their impact on the environment. Kevin Conrad and his colleagues from the University of Maryland and California State University Long Beach will soon be searching for more of these structures. He proposes calling structures like the Melanesian Marginal Plateau oceanic mid-plate superstructures to distinguish them from the large magmatic structures formed by a single massive volcanic event. Ultimately, these discoveries about deep-sea geology and volcanism bring us one step closer to answering how life originated on our planet. For although the theory regarding deep-sea volcanoes is widely accepted, no one knows exactly how biological structures form there. Despite all our technological advances, no scientist knows how to create life from inanimate substances. The latest discovery could be a step towards solving this mystery. To find out, we're diving into the Clarion-Clipperton Zone, a vast area in the Pacific Ocean between Hawaii and Mexico. Here, at a depth of 4,000 meters, researchers have found a mysterious source of oxygen that appears to function independently of sunlight and photosynthesis. On Earth, most oxygen is produced by plants, plankton, and certain bacteria that use sunlight to convert carbon dioxide into water, sugar, and oxygen as a byproduct. However, no sunlight reaches a depth of 4,000 meters. It becomes pitch black as early as 200 meters down. And yet researchers have found a source of oxygen. While investigating the seafloor in the Clarion-Clipperton Zone, they encountered areas where the oxygen concentration was suddenly significantly higher than in the surrounding area. And not only that, the concentration continued to rise over a period of 48 hours. They repeated their measurements several times and even verified them using different methods. The result was always the same. Something down there in the deep sea is producing oxygen. So where does this dark oxygen, as the researchers call it, come from? The researchers have a fascinating theory. It could be a kind of natural electrolysis. You may remember electrolysis from chemistry class. In this process, water is broken down into its components, hydrogen and oxygen, using an electric current. Normally, you need a power source for this, but in the deep sea, there's no electricity, right? Actually, there might be. Scientists have measured an electrical voltage of up to 0.95 volts between different points on the surface of manganese nodules. Manganese nodules are potato-sized lumps of various metals that lie on the ocean floor. And it is precisely these nodules that could function like a natural battery and split seawater into hydrogen and oxygen. This discovery could fundamentally change our understanding of where and how life originates, at least as far as the origin of oxygen-breathing organisms is concerned. If there is a way to produce oxygen without sunlight, that opens up entirely new possibilities. Think of all the places in the universe where we previously thought life was impossible because there isn't enough sunlight. The oceans beneath the ice layer of Jupiter's moon Europa, for example, or the methane lakes on Saturn's moon Titan. If processes similar to those in the Clarion-Clipperton Zone were occurring there, then life would suddenly be possible in places we previously considered absolutely inhospitable. This discovery could also explain how life on Earth originated. Perhaps there was already life in the depths of the primordial oceans long before the first photosynthetic organisms enriched the atmosphere with oxygen. That would completely turn our understanding of the evolution of life on Earth upside down. And as if that weren't enough, this discovery could also have very practical applications. Imagine if we could mimic this process and produce oxygen on a large scale. Perhaps in the future, we'll see massive underwater oxygen farms supplying our cities with fresh air. Scientists are already planning to take more samples from the Clarion-Clipperton Zone and closely examine what's going on down there. Maybe they'll discover even more surprises. Who knows, maybe they'll even find the underwater civilization that's been living peacefully for millions of years and wondering why we humans on the surface are always causing so much stress. I hope you're all deep sea experts now. I'll keep you updated here on the channel about all future discoveries in our planet's oceans. So if you haven't already, hit that subscribe button now. Thanks a lot, everyone. And speaking of mysterious discoveries beneath the surface, do you know what researchers recently found beneath the Sahara? Evidence of a highly advanced civilization that may have existed long before the ancient Egyptians. This discovery could turn our entire understanding of history upside down. To learn all about these findings, be sure to click on the video displayed in the top right corner. It's very exciting. And if you click in the bottom left corner, you can order the shirts from the videos and cute plush planets in the space shop. Every order really supports my work. Thank you so much. And other than that, I'd say see you in the next video. Take care, everyone.